Okay, thank you very much. Hi, everyone. My name is Dimitris Kyriakoudis. I'm currently a third-year part-time PhD student at the University of Sussex, working with Chris Kiefer and Thor Magnusson. And a little bit of context, my undergraduate, I come from a classical music background, so I started learning piano as a kid, and then got into rock and discovered electric guitars. Synthesizers, and it's been a whole journey that led me to studying music computing at the University of Goldsmiths, where I discovered computer music, and that was a whole other rabbit hole to go down. And so this all kind of contextualizes what this research is about, which is about live coding and its ergonomics, its ergodynamics, and a term that I like to call ergologics. And so as a programmer and as a native Greek speaker who has a particular interest in etymology, I'll define a few terms. Ergonomics comes from the Greek words ergo and nemo. And nemo or nomos, nomos means law, but nemo means to distribute. And so when we're thinking about ergonomics, we usually think about how much does this damage my body? How easy is it to work with? But originally, I believe ergonomics used to mean how is the work distributed? Where does it go? And are we using the right resources to do the right tasks? Ergodynamics, again, ergo is a big part, means work. Dynamis means strength. And so ergodynamics, and also potential, so potential and strength. And ergodynamics is the potential of an object to make some kind of work and how it does that. But also, in a lot of ways, I understand it to mean how that is communicated to an individual, and sort of how easy is it to pick up these latent potentialities that tools have. Lastly, ergologics. As far as I know, I made up this word. I haven't found it anywhere yet. And it's a very simple one. It's about what the actual logic is behind the way that work is being done. So how do things actually happen? What's actually happening in an instrument that we're interacting with? I've been thinking a lot about human-computer interaction as a term, and sort of trying to define things. I've been asking myself, what is it that we're actually interacting with? A computer is a kind of a nebulous concept. It's a machine that, at least modern computers are machines that can almost literally shapeshift and assume the functionality of other information machines that we can describe to them. So in a lot of ways, it's not so much a thing that we're interacting with, it's a mirror that can embody ideas as we can describe it to it. And then we're interacting with those ideas in the way that they are reflected back to us in a feedback loop. And so interacting with a computer, in a lot of ways, we're interacting, there's a surface level, there's the computer as a physical object, and there's a keyboard and a mouse and a display, but then I'm also interacting with the software that's on it, but then ultimately I'm interacting with a shape-shifting machine. And so interactions are mediated through whatever it is that I can accurately describe to it, or someone else has in the past. And so that begs the question, what kind of machines do we want our computers to assume? And that's a big part of sort of the motivation behind the research, is figuring out what kinds of machines I want to be making music with. So coming from a sort of performing instruments background, I miss the embodiment that you get. I miss the tactile feedback, the kind of losing yourself in the moment and feeling right at the edge of time flowing. And so going back to what a computer is, this is what computers used to be. They were people. They were people who were really good at doing calculations, and they were employed by labs and science agencies to perform computations. They were literal computers. And then they were all kind of replaced by these machines that were formulated in such a way that theoretically they could compute anything that these people could. And I don't really like the term human-computer interaction. I like to think of a term as more of a sort of linguistic superposition. It's all of these things at the same time, all possible paths. We're interacting with a computer, but we're also interacting with our own imagination. The computer is nothing more than a piece of paper that gets animated as we put things on it. But then the computer and the imagination are also having an interplay between them. And we are interacting, but we're also communicating, and it's not it's not just as simple as computer-human interaction. I think a lot of what computers mean to us is a lot of what we use them for is for communicating with other people, but also mostly with our own selves. And I find that a lot when I'm writing music is I'm trying to work through an idea, and I'm throwing possible suggestions at the computer, and the computer throws feedback back at me, and that whole feedback loop is, I feel it as me playing with my ideas, not necessarily with sort of an external object. Computer science as a field is not very old, certainly not when compared to other scientific fields. But there's something that's very interesting with that field, which is that we tend to forget its history. I started studying computer science at university, and my first interaction was MaxMSP, which is not a sort of that old of a software system. And then a few programming languages were introduced to me, but all of them more or less were established in the 90s, maybe some in the late 80s. And I didn't learn anything before that. I didn't know what computation was like before processing and MaxMSP and open frameworks. And so at the first stages of my PhD, I was looking at the history of the field and what ideas might have been really interesting but kind of faded away for various reasons. The first one that really caught my interest were Lisp machines, and Emacs in a way I put into a similar category, even though it doesn't have its own hardware to run on. But what Lisp machines had, that's what was very interesting, is that the entire operating system and the entire computer itself lived under one roof. Everything was there, everything could talk to everything else, and they all spoke the same language, and the hardware was designed for that language. It wasn't hardware that some engineer in the other side of the world designed and you bought, and now you're trying to make the best of it. And Emacs is this kind of weird beast. It's much, much older than I am, and it's one of the oldest sort of pieces of software still in active use today. And it had this kind of, the ergodynamic of working with it was this sense of I can do anything. It might not look great, but I can do it with the system. It's a kind of, it's a workbench for me to build the tools that I want to use. And then, of course, there are historical milestones such as Sketchpad by Ivor Sunderland, which interestingly precedes things like the C programming language, which we think is kind of ancient, by about a decade or so. And it used direct manipulation. It used modality switching with a keyboard, using the left hand. And it also interestingly featured constraints. It featured programming with constraints for the first time. Instead of just telling the computer what to do in order to achieve a desired result, you state what the desired result is. And in this case, if you wanted to draw a house, you would draw 2 lines, point at them, and say they should be parallel. And of course, things like Smalltalk, this is a modern sort of reincarnation of it, are systems that are designed to be fully introspectable, fully customizable, and more importantly, systems that are designed to help you navigate them. They have a kind of self-awareness almost of what they're made up of, and sort of how we can go through that. A lot of ideas came really early in the field of computer science, and it took decades for them to be used in a sort of more wider context other than academia. A lot of these came out of Lisp, was a very influential language. But then logic programming, Prolog, this idea that I can state to the computer that a relationship between a parent and a child is such that if my parent has a different parent, then they're my grandparent. And then I can chain together these small ideas, these small rules, build something really huge, and then leave holes where I don't know the information, and the system will try and sort of fill in the gaps. It's this idea that I'm talking about what is rather than how to get to it, or how it looks in memory. Rules engines are a particularly interesting one. It's something that came out of the academia in the, I think it was early 70s, and they completely turn the whole sort of paradigm of programming a computer on its head. And it says, instead of telling the computer what to do, you you give it a database full of data, and then you say, whenever you see data that looks like this is what should happen. It's this idea that you break down a problem not into small steps, but small pieces of the logic that piece it all together. And there's a lot of inspirations from projects that are around today. So one of my favorite one, and one of the more influential ones, MaxMSP, has this beautiful potential to become its own documentation. It's a self-documenting tool in a lot of ways. There's a lot of things I don't like about it. Mouse usage, I suffer from tennis elbow syndrome for over a decade now, so ergonomics is a big part of me being able to keep doing what I love, and not just a nice to have. But it has this beautiful ability to visualize what's happening in your patch, and you do that as you go, and you build on top of that. Gibber is a great example of doing that with text-based programming languages, and it has oscilloscopes. It can replace pieces of code with their own values, their own output. It visualizes events as they're happening, but it's still very much like a 2D matrix. It's a 2D matrix of characters that you have to manually navigate through and type. Then we have slightly more out there projects like Fracture. Fracture standing for Functional Structural Editor or something like that. Has this, it thinks of code as a structure, and it projects that structure so that when what you're interacting with is not really the visualization, the text, that then needs to be parsed and sort of put together into a structure that means anything, rather than just a sequence of characters. You interact with the underlying structure already, and then that just gets visualized every time something changes. So in a lot of ways, we're not interacting with what the visualization is. We're interacting with the underlying structure, and then the visualization just naturally follows. OrrenoLisp is a great live coding language that I haven't really seen much out in the wild. There's this one YouTube video, and it has this amazing ability to kind of visualize values as they're changing in the patch. So you'll see at some point they enter something that will go from 1 to 12 over 16 seconds, and it keeps track of the progress, and when it gets to that point, it replaces itself with a final value. So this idea that the code itself is a function of time, it's not just the output that it produces. SAPF is James McCartney's latest project that he hasn't released yet, but there's a video on YouTube, which I am afraid I don't have much time to show, but it plays with this idea of you have one program, one graph of nodes and computations, and there are multiple different ways to visualize it. So you can project it as a series of blocks or as a series of recursive kind of nodes that contain other nodes and relationships between them. It really tries to move away from this idea of there's one language, there's one underlying representation, and to change any of that, you need to start from scratch and write it again. Lastly, the demo scene is an interesting example of live coding, in this case visuals, so not necessarily music, but live coding as a function of its domain. And so this idea that you don't have a cube that it lives right here anymore, but you have a function that describes the entirety of space, and if you happen to be at the point where the cube is, then that pixel will be colored that way. But it's all a continuous kind of space. There's no discrete object and position as such. And that made my crappy laptop at the time be really capable of making some things. So I'll very quickly run through the project timelines. It's a project that I started for my undergraduate, and I'll very briefly show you what some of the code looks like. It's a project that was inspired a lot by Sonic Pi, actually, in that it tried to bundle together the editor and kind of to make the whole thing kind of be a self-contained instrument rather than pick your own editor, pick your own compiler and interpreter and your own audio engine. And so it was this idea, it was inspired by tidal cycles quite a bit, but it played on a completely different paradigm, which is what happens if my instrument has parameters, and each of those parameters varies over time, and I only specify that using functions, mathematical functions, like f of x equals x plus 1. And there's a lot that came out of that, one of the most important one being frustrations. There was a lot of parts in the way that that was being implemented that meant that I couldn't move it further unless I went back and redesigned it from scratch. So this idea of ergologics, when you're designing an instrument and trying to implement it yourself, is there's no such thing as an implementation detail. It all matters at the end, whether it affects performance or some other aspect of the instrument. USEEK was a project trying to kind of bridge together the worlds of live coding and modular synthesis. It's a part of the Mute Lab at Sussex, so Chris Kiefer and I worked on this little module. Here you can see many different versions of it, including a 3D printed faceplate. The whole thing is meant to be a very cheap computer that you put in your system. You put multiple of them in your system. It's a Raspberry Pi Pico, and then you live code through all of that. Interaction with it can happen in any number of different ways, through a tablet, a keyboard, but again, trying to kind of reconsider how it is that we're interacting with these devices, including what the keyboards look like. So there's no reason why my keyboard needs to look like a typewriter from the 1800s. And in fact, there are many reasons why it shouldn't, one of them being my tennis elbow. Lastly, controllers that are not even usually used for programming. There's no reason why gamepads and, in this case, a handheld device couldn't be used. And other interfaces, there's no reason why my computer could not be able to track where I'm looking and use continuous controllers to vary parameters as I'm looking at them. Why would I need to navigate a cursor somewhere when we have the technology to track our eye gaze and kind of make the computer know a little bit more about what we're doing with it? Lastly, time. I don't really have all that much time to go into that, ironically. But it's this idea that automation curves for everything, but the automation curves do not have to be linear. And so I'll leave you with a few snippets of code that will probably mean nothing to you. But for me, time, this is the definition of time. It's a function that, given an input, is just that input. Time itself is a thing that always returns its own flow. And so what happens when I try and add functions together? That's a kind of higher level way of looking at time. I've already talked a bit about my kind of hopes and wishes for the future, but systems that understand themselves. I want and I hope for systems that have introspection, so that I can ask questions of them and help me kind of navigate the massive amounts of complexity that we've undertaken. This is the current sort of repo for the project. It's currently a complete mess of 5 different ideas that can potentially come together to make something great, but they're all kind of inspired by this idea that our computers don't have to look and act and think the way that they have so far. Thank you.
I think we've got time for one question, if anyone's got anything that they want to ask.
So thank you so much for this. And my question is essentially, do you think there's a link between the present state of technology in some sort of sense and the metaphors and ideas that are currently, for example, used to develop tools or software? And in turn, do you think that, for example, pushing a certain metaphor or a certain idea would push as well, like the development of technology in a certain direction? What's your take on this?
Yeah, absolutely. I mean, we live in a world where, for better or for worse, certain technologies have dominated over others. There's a reason why, if you want to work in the industry, you need to use C++ and not Smalltalk or Lisp. And some of those reasons are good, some of those aren't. I'd argue that most aren't. They're just historical reasons that tie into the industry. And there's a whole talk by Alan Kay on how the industry has kind of hijacked good ideas and push them in directions that were for their own interest. I think that pushing this metaphor of computers being able to reflect, not just on their own source code, but the whole point of that source code, us explaining high-level goals rather than go over there and take this number and add it over here and do all these sort of very imperative structures, that instantly makes us think of what it is that we're trying to achieve in different ways. And more importantly, it makes tools that work in different ways. Ergologics sort of always show through the cracks, and you have instruments that are more or less malleable exactly because of the way that they were built. The best analogy that I can give is actually a quote. I don't remember who it's by, but it's talking about a diamond and how it's so structurally kind of perfect and specific that you can hardly add or remove anything without just making it not be what it is anymore, versus a ball of mud, which is a kind of a metaphor for systems that can always take in more and still be what it is that they are. And yeah, so I definitely think that we need to rethink the metaphors that we use to think about how we're interacting with the computers.
Excellent. Thank you very much, Dimitris. Thanks for the talk.